Hello friends, welcome to UGCE PG Pathshala. I am Dr. Lubna Siddiqui, Assistant Professor, Department of Geography, Jamia Millia Islamia, New Delhi. Today I am going to discuss about the module Smog and Acid Rain, which comes under the paper Environmental Geography. The objectives of this module are: number 1, define smog and acid rain; number 2, highlight the sources of smog and acid rain; number 3, formation of smog and acid rain; number 4, consequences of smog and acid rain; number 5, state methods for the prevention of smog and acid rain. Now, introduction of smog. The word smog is a combination of fog, smoke and fumes released by mills and factories, homes and automobiles. The term was invented by Des Vaux. Smog causes a smoky, dark atmosphere to arise over cities. It decreases visibility and creates a haze throughout the area. Numerous studies have monitored smog throughout the world. In many areas around the world, smog has reached extraordinary levels. Some of the world's dirtiest cities have millions of inhabitants, all of whom are threatened by the smog. Modern Los Angeles suffers severely from smog, as London did in the 19th century. These two areas released certain chemicals into the air and created a foggy atmosphere. In London, where fog levels have now fallen far below those of years ago, people were often unable to see their hands and sometimes could not walk around. It took a long time for government to act to control smog. The Environmental Protection Agency now measures levels of smog and regulates smog producers. Despite government action to reduce them, smog levels remain very high in many cities. Even those areas that do successfully reduce smog may be the victims of smog blown in from other locations. Modern smog is a type of air pollution derived from vehicular emission from internal combustion engines and industrial fumes that react in the atmosphere with sunlight to form secondary pollutants that also combine with the primary emissions to form photochemical smog. A new type of smog known as photochemical smog was first observed in Los Angeles in the 1940s. Manila and Mexico City also experiences this kind of smog. Many other cities in Greece, Israel, Japan, Australia, India and the UK have subsequently been found to suffer from photochemical smog. A photochemical smog is the chemical reaction of sunlight, nitrogen oxides and volatile organic compounds in the atmosphere, which leaves airborne particles called particulate matter and ground-level ozone. Nitrogen oxides are released by nitrogen and oxygen in the air, reacting together under high temperature, such as in the exhaust of fossil fuel burning engines in cars, trucks, coal power plants, and industrial manufacturing factories. VOCs are released from man-made sources such as gasoline, that is petrol, paints, solvents, pesticides, and biogenic sources such as pine and citrus tree emissions. Photochemical smog is a unique type of air pollution which is caused by reactions between sunlight and pollutants like hydrocarbons and nitrogen dioxide. Overall, there are two types of smog. Number A, classical smog. It occurs in cool, humid climate. It is a mixture of smoke, fog, and sulfur dioxide. Chemically, it is a reducing mixture, and so it is also called as reducing smog. Number B, photochemical smog. It occurs in warm, dry, and sunny climate. The main components of the photochemical smog result from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Photochemical smog has high concentration of oxidizing agents and is therefore called as oxidizing smog. Photochemical smog is also called PAN, that is PAN smog, due to the formation of peroxyacetyl nitrate or PAN and ozone, which are formed from hydrocarbons and nitrogen oxides in the presence of solar radiation. PAN and ozone are called photochemical oxidants. Both of these are toxic irritants to human lungs. Now, causes of smog. Smog is caused by many factors. The smog that enters the atmosphere consists of over 100 chemicals, many coming from different sources. Particulates present in smog include carbon monoxide, dirt, soot, dust, and ozone. To really create the smog effect, sunlight, hydrocarbons, and nitrogen oxides have to mix together. Major producers of smog include automobiles, fires, waste treatment, oil production, industrial solvents, paints, and coatings. Car engines, especially diesel engines, as well as gas stations that allow gas to be leaked out, are huge contributors to the smog problem. Gas vapor that gets away from gas pumps contributes to the hydrocarbons needed to form smog. Diesel engines emit particles of soot that enter the atmosphere. Lead is also a major problem, especially when found in gasoline that is combusted in automobiles. The third world nations remain dependent upon cheaper leaded gas. Today, the smog problems created by cars are becoming increasingly severe. As gas prices decline, consumers are buying cars that use more gas and hence pollute the atmosphere to a greater extent. Major air pollutants responsible for photochemical smog are carbon oxides, that is CO, CO2, nitrogen oxides, and nitric acid, that is NO, NO2, HNO3, sulfur dioxide, and sulfuric acid, that is SO2, H2SO4, particulates, that is SPM, ozone, that is O3, volatile organic compounds, that is VOCs. The reactions that lead to the formation of photochemical smog are irritated by sunlight and involve hydrocarbons and nitrogen oxides emitted from automobiles. Photochemical smog, that is mainly automobile pollution from the burning of coal and oil, contains sulfur oxide, sulfur trioxide, soot and ash, that is particulate matter, and sulfuric acid. It can cause breathing difficulties in humans, plus acid rain damage to plants, aquatic systems, and metal or stone objects. Now, formation of smog. Number A, suitable conditions for smog formation. Certain conditions are required for the formation of photochemical smog. Number A, ultraviolet light. Number B, hydrocarbons. Number 3, nitrogen oxides. The other conditions include: number 1, emission rates of the sources of nitrogen oxides, that is NOx, and volatile organic compounds, that is VOC. High concentrations of these two substances are associated with industrialization and transportation, which create these pollutants through fossil fuel combustion. Number 2, the time of day is a very important factor influencing on the amount of photochemical smog. Number 1, early morning traffic increases the emissions of both nitrogen oxides and no methane hydrocarbons, that is NMHC, a type of VOCs, as people drive to work. Number 2, later in the morning, traffic reduces and the nitrogen oxides and volatile organic compounds began to react to form nitrogen dioxide and increase its concentration. Number third, as the sunlight becomes more intense later in the day, nitrogen dioxide is broken down and its byproducts from increasing concentrations of ozone. Number four, at the same time, some of nitrogen dioxide can react with the volatile organic compounds to produce toxic chemicals such as PAN. Number fifth, as the sun goes down, the production of ozone is stopped. The ozone that remains in the atmosphere is then consumed by several different reactions. Number one, meteorological factors are important in the formation of photochemical smog. These conditions include 1. Precipitation can reduce photochemical smog as the pollutants are washed out of the atmosphere with the rainfall. Number 2. Winds can transfer photochemical smog away, replacing it with fresh air. However, the problem may arise in distant areas that receive the pollution. Number 3. Temperature inversions can enhance the severity of a photochemical smog episode. If a temperature inversion is developed, the pollutants can be trapped near the Earth's surface. Number 2. Topography is another important factor influencing on how severe a smog event can become. Communities situated in valleys are more susceptible to photochemical smog because the hills and mountains surrounding them tend to reduce the airflow, allowing for pollutant concentrations to rise. In addition, valleys are sensitive to photochemical smog because relatively strong temperature inversions can frequently develop in these areas. B. Formation of smog. When fossil fuels are burnt, a variety of pollutants are emitted into the Earth's troposphere. Two of the pollutants that are emitted are hydrocarbons, that is unburned fuels, and nitric oxide, that is NO. When these pollutants build up to sufficiently high levels, a chain reaction occurs from their interaction with sunlight, in which NO is converted into nitrogen dioxide, that is NO2. This NO2 in turn absorbs energy from sunlight and breaks up into nitric oxide and free oxygen atom, as shown in the following equation. Oxygen atoms are very reactive and combine with the O2 in air to produce ozone, as shown in second equation. The ozone formed in the above reaction, that is 2, reacts rapidly with the NO, that is G, formed in the reaction number 1 to regenerate NO2. NO2 is a brown gas and at sufficiently high levels can contribute to haze, as shown in the following equation number 3. Ozone is a toxic gas and both NO2 and O3 are strong oxidizing agents and can react with the unburned hydrocarbons in the polluted air to produce chemicals such as formaldehyde, acrolein, and peroxyethyl nitrate, that is PAN, as shown in the following equation. Formaldehyde, acrolein, and peroxyethyl nitrate. Now, effects of smog. Smog is a serious problem in many cities and continues to harm human health. When an area becomes covered in smog, the people feel the effects immediately. Unlike other problems, which may be harder to understand and visualize, smog creates immediate problems that everyone will experience. Smog is not only a city problem. As smog levels increase, winds are carrying smog away from urban areas and harming people and ecosystems far away. Smog can cause, number 1, minor pain to deadly diseases such as lung cancer. Number 2, ruins people's lungs to an extent as great as that of cigarettes. Number 3, human body has difficulty defending itself against the harms of smog. Number 4, can irritate and inflame pulmonary membranes, causing chest pains, coughing, and throat irritation. Number 5, other illnesses such as colds and pneumonia can also be brought on by exposure to smog. Number 6, people with asthma problems are under an even greater threat. Number 7, Mexico City has the world's worst levels of smog. As a result, children and the elderly are advised not to live in the city. A. Effects on materials. Smog can also accelerate the deterioration of rubber, plastics, paints and dyes, damage to metals, stone, concrete, clothing, rubber and plastic is directly related to contaminants in the air. The typical culprits are sulfur dioxide, sulfuric acid, ozone, that is photochemical smog, and nitric acid, that is HNO3. Now B. Effects on humans. Photochemical smog causes serious health problems. Both ozone and PAN act as powerful eye irritants. Ozone and nitric oxide irritate the nose and throat, and their high concentration causes headache, chest pain, dryness of the throat, cough and difficulty in breathing. Evidence reported by the Environmental Protection Agency also suggests exposure to ozone reduces immune system responses, especially in the lungs. These effects subsides over time, but little is known about the long-term effects of repeated exposure. Now C. Effects on agriculture. Agriculture is also hurt by smog. Soybeans, wheat, tomatoes, peanuts, lettuce and cotton are all subject to infection when exposed to smog. Damage to crops and materials alone amounts to roughly $10 billion a year. Now D. Areas affected. Smog can form in almost any climate where industries or cities release large amounts of air pollution such as smoke or gases. However, it is worse during periods of warmer, sunnier weather when the upper air is warm enough to inhibit vertical circulation. It is especially prevalent in geologic basins encircled by hills or mountains. It often stays for an extended period of time over densely populated cities or urban areas such as London, Atlanta, Houston, Phoenix, Las Vegas, New Delhi, New York, Cairo, Los Angeles, the Randstad or Ruhr area, and can build up to dangerous levels. Now, control measures for smog. Smog can be decreased by limiting those processes that create it. Governments are combating smog in several ways. Number 1, laws are encouraging producers of automobiles to develop cars that produce less smoke. Number 2, chemical companies are being washed over and restricted from producing certain harmful substances. Number 3, national solutions which often deal with large plants that produce smog. Number 4, local and individual efforts are underway as well. The various techniques and methods used to control the formation of photochemical smog includes A. Catalytic converters, three-way catalyst. The present strategy is to reduce vehicle emissions by catalytic conversion of the exhaust gases. Typical converters consist of a layer of precious metal such as PT or RH coated on an alumina substrate acts as a three-way catalyst to convert. Now B. Diesel. The emissions of unburned hydrocarbon and CO are markedly better from diesel-powered cars. NOx emissions are only marginally worse than those from gas cars with efficient catalytic converters. However, they have increased particle emissions. Number 1, NO to N2. Number 2, CO to CO2. Number 3, hydrocarbons to CO2 plus H2O. Number 4, conversion efficiency nearly 90% is possible for all three gases. Now C. Biodiesel. Recently, biofuels have been the focus of attention as a possible means of reducing greenhouse gas emissions and noxious urban emissions from transport. Now D. Hydrogen and electricity. H-powered and electric vehicles are cleaner on the road. H2 produces water and electric cars have no emissions at all. However, the pollution audit must include emissions due to the generation of the H2 or of the electricity. Now E. Lifestyle changes. Small decreases in legal speed limits not only conserve fuel but significantly reduce NOx emissions with a negligible increase in hydrocarbon. Increased uses of public transportation also reduce photochemical smog. Now F. Polycyclic aromatic hydrocarbons, that is PAH. PAH are caused by incomplete combustion. Anthropogenic sources include motor vehicles, both diesel and gas, stationary power plants, that is coal and oil, domestic, that is coal and wood burning, tobacco smoke, as well as deliberate biomass burning. The compounds are ubiquitous in the atmosphere. A small contribution to the atmospheric load of PAH may come from natural sources such as forest fires or volcanoes, but the predominant sources are anthropogenic, important due to their impact on human health. Now, second part is acid rain. Acid rain is a widespread problem found all over the world. It is the result of chemicals from burnt fossil fuel mixing with moisture in the atmosphere and falling to the ground as rain, snow, sleet, etc. Acid deposition is a more precise name than acid rain because acid can fall to the ground as rain, snow, sleet, hail, and anything else. It can also combine with dry particles and fall to the ground. Therefore, it is called dry deposition, whereas acid coming down in rain is called wet deposition. Acid rain refers to the ways in which acid from the atmosphere is deposited on the Earth's surface. The term acid rain refers to what scientists call acid deposition. It is caused by airborne acidic pollutants and has highly destructive results. Scientists first discovered acid rain in 1852 when the English chemist Robert Agnes invented the term. From then until now, acid rain has been an issue of intense debate among scientists and policymakers. Acid rain, one of the most important environmental problems of all, cannot be seen. The invisible gases that cause acid rain usually come from automobiles or coal-burning power plants. Acid rain moves easily, affecting locations far beyond those that let out the pollution. As a result, this global pollution issue causes great debates between countries that fight over polluting each other's environments. For years, science studied the true causes of acid rain. Some scientists concluded that human production was primarily responsible, while others cited natural causes as well. Recently, more intensive research has been done so that countries have the information they need to prevent acid rain and its dangerous effects. The levels of acid rain vary from region to region. In third world nations, without pollution restrictions, acid rain tends to be very high. In Eastern Europe, China, and the Soviet Union, acid rain levels have also risen greatly. However, because acid rain can move about so easily, the problem is definitely a global one. Now, causes of acid rain. Scientists have discovered that air pollution from the burning of fossil fuels is the major cause of acid rain. The primary causes of acid rain are sulfur dioxide and nitrogen oxides. These chemicals are released by certain industrial processes, and as a result, the more industrialized nations of Europe as well as the US suffer severely from acid rain. Most sulfur dioxide comes from power plants that use coal as their fuel. These plants emit 100 million tons of sulfur dioxide, 70% of that in the world. Automobiles produce about half of the world's nitrogen oxide. As the number of automobiles in use increases, so does the amount of acid rain. Power plants that burn fossil fuels also contribute significantly to nitrogen oxide emission. Though human causes are primarily responsible for acid rain, natural causes exist as well. Fires, volcanic eruptions, bacterial decomposition, and lightning also greatly increase the amount of nitrogen oxide on the planet. Burning fossil fuels sends smoke and fumes into the atmosphere or the air above the earth. In the air, these pollutants combine with moisture to form acid rain. The main chemicals in air pollution that create acid rain are sulfur dioxide, that is SO2, and nitrogen oxide, that is NOx. Acid rain usually forms high in the clouds where SO2 and NOx react with water and oxygen. This forms sulfuric acid and nitric acid in the atmosphere. Sunlight increases the speed of these reactions, and therefore the amount of acid in the atmosphere, rainwater, snow, fog, and other forms of precipitation then mix with the sulfuric and nitric acids in the air and fall to earth as acid rain. Now, formation of acid rain. We are aware that normally rainwater has a pH of 5.6 due to the presence of H+ ions formed by the reaction of rainwater with carbon dioxide present in the atmosphere, as shown in the following equation. When the pH of the rainwater drops below 5.6, it is called acid rain. Acid rain is a byproduct of a variety of human activities that emit the oxides of sulfur and nitrogen in the atmosphere. As mentioned earlier, burning of fossil fuels which contain sulfur and nitrogenous matter produce sulfur dioxide and nitrogen oxides. SO2 and NO2 after oxidation and reaction with water are major contributors to acid rain because polluted air usually contains particulate matter that catalyzes the oxidation. It is shown in the following equation. Figure 1 shows the formation of acid rain. Now, effects of acid rain. The problem of acid rain is rapidly spreading because it is mainly caused by industrial processes, automobiles and power plants. Those countries that are developed have the most severe acid rain problems. However, as the undeveloped nations begin to industrialize, acid rain will increase greatly. Bodies of water such as lakes and rivers see many of their inhabitants die off due to rising acidity levels. Acidic water also ruins plant nutrients, hurting plants' ability to survive and to give life to other organisms. Human-made products are also experiencing degradation from acid rain. Cars can lose their finishes and outdoor statues are beginning to rust. Acid rain's effects are destructive and long-lasting. Though scientists have studied lakes, streams, and many other natural ecosystems to prove its negative effects, acid rain continues to be produced and is increasing in many parts of the world. Some of the effects of acid rain are listed below. Number 1, excessive acid concentrations are phytotoxic, that is toxic to plants. There have been widespread deaths of trees in forests due to acid rain. Number 2, sea waters are rich in minerals and have great buffering capacity. But buffering capacity of freshwater bodies is low and acid deposits have a toxic effect on the freshwater ecosystems. Number 3, mature, that is capable of reproduction. Fish survives in acid rain-fed water bodies but fails to reproduce. So, there are no young fish in such waters. Number 4, exposed surfaces of buildings, statues get corroded. Limestones or marble, that is CaCO3 structures, are especially damaged. The chemical reaction is like as shown below. The sulfates are leached out by rainwater. Number 5. Acidic sulfate when present in the atmosphere causes laziness. Acidic mist falling on the ground reduces visibility. Now, control measures of acid rain. Debate over acid rain and ways of preventing it have raged between environmentalists and corporations. Policymakers and environmental experts are now looking into the best methods to limit acid rain. Environmentalists advocate the installation of sulfur cleaning scrubbers in factories, washing sulfur out of coal, and finding new methods of burning coal. Power plant operators are looking for less expensive solutions to the problem. Individuals can help by conserving energy or driving their cars less. Governments can pass laws restricting pollution levels or can use a variety of methods such as tradable emission permits to reduce acid rain. Whatever way it is done, acid rain will certainly have to be limited in the future. Some of the solutions includes are: number A, all the factories are required to be outfitted with scrubbers. They are very expensive to maintain, but they remove 95% of sulfur dioxide after coal is burned. In scrubbers, poisonous gases are sprayed with a mix of water and lime. Together, the sulfur, water and lime form a grey, gooey substance called sludge. Number B, another solution to lake acidity is liming. Lime is very alkaline, so when poured into lakes, it cancels out the acidity. The problem with liming is that it is very expensive and only temporarily reduces acidity. Number C, another solution is something called a catalytic converter, which is required on all cars. The converter is mounted on the exhaust pipe, forcing all exhaust to pass through it. This converts nitrogen oxides, carbon dioxides, and unburned hydrocarbons into a cleaner state. There are many attempts to clean our air, but the atmosphere is still a long way from being clean. If attempts to clean our air continue, our rain may return to normal and acidic lakes over a period of time would return to normal. But if our attempts to clean up our own mess fail, we may cause ourselves to kill all our natural resources, which would lead to the extinction of all life on this planet, even humans. Now, conclusion. Smog and acid rain are produced through similar sources, primarily vehicle and industry emissions. Though both result from human-caused air pollutants, these are chemical distinctions between the two. Though there are regulations in effect to reduce both types of pollution, they remain a threat to both human health and the environment. I hope you have understood the concept of smog and acid rain. See you next time. Thank you.